Good evening. Welcome to Sriveda IT. This is DS Prasad, an AI engineer. Today we are going to learn about what is deep learning. So deep learning is subset of machine learning. That uses artificial neural networks, artificial neural networks with multiple hidden layers, multiple hidden layers to automatically learn patterns and features. So features from large amounts of data, large amounts of data, enabling computers to perform tasks such as image recognition, speech recognition, object detection, and face recognition. Also, machine translation, machine translation, also chatbots and LLMs. So chatbots and LLMs. Okay. So deep learning is a subset of machine learning. So it is a subfield of machine learning. It uses the artificial neural network with multiple hidden layers, and these networks will automatically learn the patterns and features. So, what do you mean by patterns and then features? If you take any image, and inside that image, this image is having some information, like any person image is there, and that person has after dividing this image like this. So we call this as a n cross m cross c. So like pixel. So pixel, which is nothing but height, width, and then channel. Channel in the sense means like, so here RGB color image or HS. So these are different type of color images. If they are present, it has three channels: red, green, and then blue. H, S, and then V. So that the image channel is three. When we take that grayscale image or black and white image, actually the channel is only one channel. Okay. And height and width represents the rows and columns. That's why I divided this image into the grid. Here in these grids, the data present, wherever the data is present, that data we are going to extract. So those extraction is nothing but called as a features, and patterns in the sense means like comparing that image with other images and understanding that what exactly the numerical data present in this grid is about what exactly the other numerical value of the other image. So that is nothing but called as a patterns from large amounts of data. So why we are considering it as a large amounts of data? Because deep learning works better for huge amount of data, where machine learning fails. Machine learning may not work for huge amounts of the data, and also here automatic feature learning is better in the deep learning, but there is no automatic feature engineering. We need to do the manual engineering in the machine learning. Also, machine learning cannot work well on the images, cannot work well on the images, text, audio, and video. So these challenges overcome in deep learning because deep learning has automatic feature engineering. It can work on the images, text, and audio, video, and better results because huge amount of data, deep learning can work very efficiently. Here, why cannot work on the images, machine learning? Because, see, we need a third party tool to convert the images into the numerical, because machine learning works on the numerical. This is called a manual process. Again, the tool may be a costly, or we don't know that whether the tool has converted the images into the numericals properly or not. So that is the biggest problem. Here, large amounts of data enabling the computers. So, meaning it is giving some kind of intelligence to the computers to perform the tasks such as image recognition. What is the meaning of image recognition? If I give any image, the machine is going to identify that image. Example, I gave a cat image, so it identifies that this is a cat. I gave a dog image. My machine can understand that this is a dog and it will give the result. And if I gave an aeroplane, so it can identify that this is an aeroplane. Okay. Speech recognition. When I'm going to give the audio of a different singers, for example, it can identify the which audio belongs to the which singer. So who is singing the song. So that kind of speech recognition. Also, we can give our voices in different ways, then it can identify that speech recognition. Object detection means, so here image recognition and object detection somehow looks very similar, but there is a major difference between them. And in the object detection, it is going to not only work on the image, it is going to work on the live, so live video, so live video capturing, and it can identify that what are the objects present surrounding. Okay. So also face recognition, which face belongs to whom, all these things in the security purpose we are going to use, and machine translation or language translation are creating the chatbots and large language models. Okay. So this is about something called as a deep learning definition. But deep learning mimics the human brain. So deep learning mimics the human brain. So what exactly this means? Here, so deep learning mimics the human brain. I'm going to consider first of all human brain. So here this human brain is having billions, so billions of neurons, and these neurons are having different parts. For example, our human body is having a parts. In the same way, these neurons are also having the different parts. And how this biological neuron is looking to be. So going to be means here I'm going to take, so a just a kind of neuron. So here, so this is a biological neuron. So which is a present with the nucleus. So here, so this is my nucleus. Okay. And here, so it is having some kind of connections. So biological neuron. Okay. So like that, it has some connections. Okay. And this biological neuron is having the parts. What are the parts that are having in our human brain? So the first one is dendrites. Okay. What dendrites do means it will receives the input signal. So receives the input signal, and it is having soma, which is called as a cell body. So it will process the information. So it will process the information. And also it is called axon. There is another part. What axon will do means it transmits the output signal. Transmits the output signal. And synapse. Synapse, which is nothing but strength of connection. So strength of connection between two neurons. So between the two neurons, okay. And this is my human brain, okay. But what is meant by artificial neural network? Here, artificial neural network. So this artificial neural network has three parts. Okay, what are the three parts? We are calling that as a layers. Okay, layers. So one is called as an input layer, another one is called as a hidden layer, and last one is called as an output layer. Output layer. Exactly what is going to happen here means, so dendrites receive the input signal in the same way my input layer receives the input signal. Okay, my input receives the inputs in the artificial neural network. Here, Soma process the information in the same way when it comes to the artificial neural network. I have the weights. We are going to do the sum of those weights and adding the bias. Similarly, Axon, what it will do means in my artificial neural network, it is having artificial activation function. So activation function, so that generates output. That generates output. So activation function that generates the output. So here I am having a synapse, right? Strength of connection between the neurons. I am having the weights connection. I am having the weights connection in the artificial neural network. Here, these two collaborations, so collaboration of these two will do these two activities, hidden layer activities and output layer activities. So how it is going to do that, we will see that. Here I am considering only one layer, so of the input, and this is hidden layer, and this is the output layer. So what exactly going to happen in this, we will see that. Here, as I told you that this is the input layer, this is the hidden layer, and this is the output layer. It is neuron, input layer neuron. This is hidden layer neuron, and this is my output layer neuron. Here, so my input like X, here X came, and there is a connection between the neurons, right? We call that as a synapse in biological neuron. But when it comes to the artificial neuron, it is nothing but weighted connections. Here I am having the weight and also the bias. Here, this neuron to output neuron, there is again one more connection and weight and then bias. And here I'm going to get the output Y. Okay. So what is going to happen here? Whenever I'm going to get this output, like weights and bias and input, here this hidden layer neuron is doing two operations. So one is belongs to the weighted sum and plus bias. Okay. Where, so I'm going to consider another variable G, which is equals to sigma I is equals to 1 to n xi wi plus b. We are going to add the bias terms. Okay. After that, so here this second phase, what it is going to do means it is having an activation function of G. Here there is a mathematical uh, activation functions are there. So usually in the real time or many most of the networks we are using the ReLU activation function. So what is the meaning of this? This follows a mathematical formula 0 comma G. If the calculated G value is maximum, then it will consider the G. Otherwise, it is going to consider that 0. So when here the activation function is 0 means do not fire neuron. Do not fire neuron. And if the maximum value is G, fire the neuron. So fire the neuron. Firing the neuron means activate the neuron. Once if the neuron is activate, information will pass from here to here. Okay, information will pass from here to here. Again, in the output layer neural network, so the phase one is same. The phase one is same. When comes to the phase two, it will also looks same, but here also activation function will be there, and the duty. So the duty of this activation function is to identify identify the class result. Identify the class result, which is nothing but called as classification or prediction. So classification or prediction it is going to do. What exactly it will do means, here I gave the input image cat. After processing, my neural network in the output layer, because of this activation function, will says that the given input image belongs to the cat. So it is identified cat image as a cat. And if I give the dog image as a dog, so like that, the output results are going to come. This is the somewhat basic network so that we are going to have. So what is going to happen in this complete from here to here? Means first it is going to learn, it is going to think, and it is going to the process. In the same way, if I ask a question to you, how your brain is receiving that question and thinking in our brain and giving the response, in the same way my neural network works. Okay. So this is about somewhat like a basic of deep learning. Okay. So we are not much into this what exactly artificial activation functions and all. Why? Because it's in the course we are going to discuss that one. So here I'm going to present one fully connected network. So how to create that fully connected so network. Here, this is my input layer. Now you can see that. And I'm going to take that output hidden layer. So this is my hidden layer and another hidden layer. Okay. And finally, I am having the so output layer. Okay. So here I'm providing the connections. So these are my inputs. These are my inputs. These are my inputs. These are my inputs. So every neuron of the input layer is connected to every other neuron of the hidden layer one. Okay. So also every neuron of the hidden layer is connected to every other neuron of the other hidden layer. Okay. So this is the thing. And here, so connecting. Okay. So what we call this one? This is called fully connected network, deep convolution or not convolution, deep fully connected network. Okay, we'll come to the convolution. So here, so this is the connection, and after that, so one more connection. So every neuron of the layer is connected to every other neuron of the other layer. So that is the thing. So here, what is going to happen? We'll see that. Okay, and finally, so here we connected this. Okay, so finally we are on to the ending. That's it. We have created a network. So this is called as fully connected deep neural network. Deep neural network. In the real time, we are going to have this kind of networks that we are going to work. This is nothing but input layer and hidden layer one, hidden layer two, and output layer. So you may have one question. So what exactly that means? How many input layers and how many hidden layers and how many output layers? And again, so number of neurons in the input layer, number of neurons in the input layer, in the hidden layer and output layer. So we don't know that one exactly. So how to design this network means if you take any input image, if you take any input image, for example, I have taken the dog image, and this dog image pixel is nothing but 64 cross 64 cross 3. So height, width, we call this as a spatial dimension. So spatial dimension, and 3 is nothing but channel. Okay. So what exactly if you multiply that one 64 cross 64 cross 3, 12288. So these many pixel values, these many pixel values, and each neuron saves one pixel value, one pixel value, meaning we need 12288 neurons where in the input layer, in the input layer. So here we are going to take that 12288 neurons in the input layer. When it comes to the hidden layer, so number of hidden layers is n. Number of neurons in each hidden layer, is n. So there is no fixed rule or no mathematical equation or formula to design the number of hidden layers or number of neurons in the hidden layers and number of layers in the number of hidden layers. When it comes to the output, yes, we can decide this output. So then only the project can work. How we are going to decide this one? Because we have three cases are there. One is nothing but if you are working on the continuous, so continuous variable, target variable, continuous target variable. So for example, profit of an organization, revenue of a government, so revenue so of the government, salary of an employee, or sales amount, sales amount, all comes under in the numerical. So all comes in the numerical. So for numerical analysis, we need only one neuron is enough in the output layer. When it comes to the classification, so like categorical. So our target variable is categorical. Here, what exactly we need means we need a example like for example you have a data like a dog and cats images. Dog is one class, cat is another class. So this will called as a binary classification. Remember binary classification. And we need two neurons in older architectures, but we need only one neuron in the latest architecture, so that we can go with the one neuron only. And if we have more than two, means dog, cat, and if I add the rat, then how many classes are there? Three classes are there. More than two means it will comes under multi-classification. So multi-classification. Actually, so this is binary classification, multi-classification. How many number of neurons that we need here means here the class size is three. So we are going to take the three neurons. Okay. So that is the thing. And here so if we take only one image, we need 12288. If we take multiplied by 100 images, or if we multiplied by 1000 images, if we multiplied by 1 lakh images, if we multiplied by 1 million images, in the real time we are going to have 1 million images. The size of the data increases, size of the data increase, and computation, so memory computation, so will increase, computations will increase, and it is not easy to process this data to the model. So to the model. So model in the sense means algorithm. So algorithm. So to overcome these problems, what exactly the engineers and scientists did, they designed an algorithm called convolution neural network. So convolution neural network. So convolution neural networks. So here what is going to happen means I'm not into much depth of convolution neural networks because just it is an introduction, and I'm going to give a brief idea about what exactly convolution neural networks means. Okay, this convolution neural networks is one of the deep learning algorithm. It is going to use work on the convolutions. Okay, so convolution operations. So convolution operations. So it is having three layers. It is having three layers. One is convolution layer, and another one is pooling layer. So pooling layer, convolution layer, pooling layer, and also flatten layer. Flatten layer. So convolution layer. So what this convolution layer will do means actually here convolution layer is going to identify uh, patterns, identify patterns and features. So this is more important. How it is going to identify the patterns and features means it is going to work on the horizontal, vertical, so vertical, diagonal, diagonal edges of the image. So edges of image. Also on the corners, curves, curves, color, texture, color, texture, and shapes. Color, texture, and shapes. So that after working on all these operations, it can identify the nose, face, object, and whatever it may be. Okay. So that is the thing. And this convolution layer is having two parts are there. Okay. So two parts. One is called as a padding, and another one is called as a stride. Okay. So padding is of two options. One is called as a same, and another one is called as a valid. So when you take that padding is equals to same, whatever the input image you give, the output image of after convolution. So input image and after convolution, the output image is also same size. Size in the sense means like pixel size. So pixel size. If you take the valid, then whatever the input image you have taken, there is a shrinkage of that image. Shrinkage means reduce. Shrinkage means reduce of the size of the image. How this is going to happen? So actually here we are performing a convolution. So how to perform that convolution means if you take that this is my input image with respect to 3 by 3 something like this matrix. So here, so this is my matrix image. Matrix in the sense means like image in the uh, grid like structure. Okay, and it is here having the numerical values like in what range that numerical values are there means 0 to 255 because R G B follows each 0 to 255. This one also 0 to 255, and here uh, some numerical values are present. Okay, and we are going to use the kernels or filters. So kernels or filters, and these are the kernel. So as I am saying that this is a kernel, right? What exactly the meaning of kernel? It is nothing but a an array. So kernel or filter. So it is a array 3 by 3 filter, 5 by 5 filter matrix or 2 by 2 filter. I am taking 2 by 2. Here 1, 2, 3, 4, 5. 1, 2, 3, 4. So 4 rows and 5 columns, 4 by 5 matrix. Okay. Usually we'll take 8 by 8 so that shrinkage we will understand very easily. So what exactly this stride? If I take that default value stride is 1, if I take that stride as 1, what will happen means this traversing of this kernel on the input image. What is the meaning of traversing means? Just look at this one. So here like a 2 by 2 matrix it is going to cover now like this is one traversing, and after that so here it will start from stride is equals to 1. This is called another traversing. Okay, next it will start from here to here. This is called as another traversing, and this is called as a so another traversing. So this is called as another traversing, like 1 2 3 4 times it traversed. Okay, when the comes to the new line, so how it is going to traverse means it is going to start from here to here like this. Okay, now you can see that this is how this kernel is going to traverse on this. For that we are taking the stride is equals to 1. If you take that stride is equals to 2 means this is the original kernel filter, so it occupies. So what exactly going to happen I will explain. Convolution means after that stride is equals to 2 means after 1 to 2 it will start from here to here. So it will start from here to here. Okay, striding means movement. Okay, this kernel movement. For example, here I am considering that the numerical values. So 1 1 0 1, and here 0 1 1 1 numerical values are there after normalization. So what will happen means convolve this. How to convolve that means just I am projecting the image values here 0 1 1 and then 1. So we need to convolve that one. 0 multiplied by 1 plus 1 multiplied by 1 plus 1 multiplied by 0 plus 1 multiplied by 1. So when you do this one, this is 0, this is 1, this is 0, and this is 1. So 1 plus 1 will give the 2. So this final output of the image is here, the pixel value is 2. I got the 2. Okay. This is convolution operation. Actually, so when we take the padding is equals to same, whatever the input image you take, 6 by 6 image, then output is also 6 by 6. If you take that valid is padding is equals to valid, 6 by 6 input image becomes 4 by 4, okay, or 5 by 5. So actually this process we are going to learn elaborator in the convolution, but just for the sake of understanding, I am explaining for the project development because I'm going to develop one deep convolution neural network project, which is highly recommended for most of the research oriented and also how to develop in the real time and what exactly that project we are going to develop. Okay, so this is the thing, and the next concept is pooling layer. What exactly this pooling layer means? Pooling layer is to reduce the spatial dimension. So spatial, so dimension, so spatial dimension. What exactly the spatial means? Spatial means height minus height by width, no channel. Okay, so this image is there, right? It is, for example, input is 6 by 6. We are using the filter again. So mostly in pooling layer, we are going to use the filter size 2 by 2. And when we convolve this 6 by 6 matrix with the 2 by 2, I am going to get a 4 by 4 output image. 4 by 4 output image. And whatever the output, this is input image. And whatever the output image that I got, this is called as a feature maps. So we call them as a feature maps. Here also feature maps. So feature maps. Okay. And there are two different concepts in the pooling layer. One is called as a max pooling and another one is called as a average pooling. We are going to use any one of them. Mostly we'll follow the max pooling only. And flatten layer. Flatten layer means converting a ND array, so ND array to 1D array. So n dimensional array to the 1D array. So this is 4 by 4, right? We need to convert that one. Why we need to convert that into the array? Array in the sense means like vector. So we are going to convert that into the 1D vector. So why we are converting that one means because, so as I told you that this is my architecture, right? Here my convolution has to perform image processing. So how this is? It is having x1, x2, x3, and then x4. Here weights will be there. So wi, this is nothing but bi. So here something wj, comma bj, so wc, comma bc, like that. So these inputs are there, right? X1, x2, x3, x4. But my image is looks like this. For example, my image is looks like this. This is after pooling. Now I want to convert into the one dimensional array. What will happen means this value reflects here, this value reflects here, this value reflects here, like x1, x2, x3. So our nine are there, x4, x5, x6, x7, and x8, and then x9. These values I am passing here to the my fully connected network so that it can perform the operations. Okay, so it can perform the operations. So up to here, this is the thing. Now what I will do means I will go for the project development. Okay, how to develop one deep learning project from end to end. Okay, and actually lot of things to cover, but I won't cover in this section. So what I have to do means just go here and look for the Anaconda prompt, and this is my Anaconda prompt. And after installation, just check that. So Honda activate OCR. So this is my environment. I created an environment and now I am working on it. So just I am typing. So Jupyter notebook. We can also work in the Visual Studio also. How to use that one in the Visual Studio? It will connect to the local host 8888 and then tree. So here, so what we have to do? Okay. So to develop any machine learning project, we need two IDs or environments. So what are those two IDs or two environments means? One is nothing but Jupyter and another one is nothing but called as uh, Visual Studio. Okay. So Visual Studio. Here, so one is Jupyter. How Jupyter will comes? Installing the Anaconda software. So Anaconda software. So here, and the next one is VS Code. After installing the VS Code, so create a environment or environment. Here also create environment. So environment. Also install CUDA. Install CUDA. So CUDA and CUDNN. So here also install CUDA and CUDNN. Sir, how to install CUDA CUDNN? If your laptop supports, okay, NVIDIA, so NVIDIA RTX GeForce RTX, so GeForce RTX. So go to settings in your system, check that. So what is the RTX number? RTX number 4050, for example. Then go to the official website of NVIDIA, look for the CUDA drivers, CUDA drivers, CUDA drivers, and then install. So for 4050, so download that around 1 GB like that and install all the dependencies. After that, also install CUDNN. So this is the version. So version you will get. So what the version will satisfy for this, you have to install that. For this RTX, which version satisfies, you have to install that. After setting up, okay, completely, then your system means laptop is ready for development of deep learning. So development of deep learning using GPU instead of CPU. GPU, graphical processing unit, instead of CPU. In real time, completely we are working on GPUs. Okay, sir, my laptop not support so CUDA NVIDIA RTX GeForce. Then what is the alternate solution? Go to Google Colab. So Collab. Google Collab, and then choose. Launch Google Collab. So go to Google Collab and launch it, and choose the GPU runtime. So runtime GPU, you can set it. Okay. So after doing this one, then only we are going to perform the project. Otherwise, we cannot able to perform the project. So deep learning. Sir, can I develop the project in CPU also? Yes, yes, but depends upon the size. So depends upon the data size. So data set size. So processing may take to develop a deep learning project around 24 hours to 1 week, or maybe 1 month also it may take. Okay. So that is the biggest problem. To overcome such a problem, we are using GPU, so that GPU can work very better. GPU can work very better, very fastly. Okay. So compared to CPU. And there is another option is the TPU, tensor processing unit. We won't understand tensor processing unit. Why? Because this is completely low level language. So that remove up to now. So keep that TPU aside in the upcoming sessions. So when TPU is initialized, then we are going to work on that TPU. So first and foremost thing, this is my Jupyter notebook. So what I have to do means whether my GPU is installed or not, I have to check that one. So how I have to check that one? First import the torch. So import torch. After that print. So print torch version. So torch version. Which torch version that I am using or installed. So which torch version? So installed. Okay. For that command, torch dot underscore underscore version. So torch dot underscore underscore. So version. Right. Okay. And also print. So print. So whether CUDA is in available or not. So CUDA is available or not. So here after that torch dot. So CUDA dot is available. So available. So is available. Similarly, after that print CUDA version. Okay. So I want to know the CUDA version also. If it is installed, then it will give that CUDA version also. After how to check that one? So torch dot version dot CUDA. So look at this difference. Torch dot underscore underscore version. Torch dot version dot CUDA. Okay. After that, so I want to know that GPU. Okay. So CUDNN. CUDNN means CUDA deep neural network version, whether it is installed or not. Okay. So CUDNN version. So CUDNN version. Okay. So whether it is installed or not. So how to check that one? Torch dot this CUDNN is backside, back end of that CUDA. So that's why the name back ends. So back ends dot CUDNN dot version. So CUDNN dot version. And after that print GPU count. So whether GPU is available or not. So GPU count. So GPU count if it is available. So how to check that one? Again here torch dot. So GPU means CUDA. So CUDA dot device count. So device count. So whether it is available or not. After that print. So print. So here GPU name, if it is available, what is the name of that? So GPU. So I would like to know, comma. So torch dot. So CUDA dot get. So device name. So get device name and mention that parameter as 0. So the first name. If available. So if it is available, how it is available? If torch dot CUDA dot is available. So is available. Then only it has to print that name. Otherwise, so else, so no GPU. Print else no GPU. So just execute this one. It is giving some kind of syntax error. So EOF file parsing. Now it is started running. Okay, here let's see that. So within a seconds, it is going to print that yes, Torch version is 2.1 and 2.5. CUDA is available. CUDA version is 12.1. CUDNN version is 90100. GPU is, yes, this is my GPU. And name of the GPU is NVIDIA GeForce RTX 4050 laptop GPU. Okay, everything is fine. Now I want to develop that project. So to develop any deep learning project, so what are the steps that I have to follow? So whatever the steps we follow for machine learning, same steps for the deep learning. So collect data. So collect data. What type of data? For example, image data. So here I have collected the image data. Next step is convert. So images. So convert images into NumPy array. So convert images into NumPy array. Why? What is the need of converting like that? Because image data is a huge size. Okay, NumPy array size is around in the KBs to MB. KBs to MB. Here in GBs, GBs will be in KBs to MB. That is the advantage without the loss of information. Everything in the numerical values. So everything in the numerical values. This is second step. After that, so load the data. So load that data, and after that, what we have to do means image data augmentation. So image data augmentation. So after that data augmentation, we have to apply the early stopping. So early stopping or model checkpoint. So model, so checkpoint, so model checkpoint. After that, build CNN. So build a convolution neural network architecture. So build CNN architecture. And after that, so here next train CNN model. So train CNN model. Okay, train CNN model. After that, test CNN model. CNN model. Okay. Next, predict. So predict um, test image. So test image. So to know how my model is working, to know how my CNN model is working. Okay. So working here, draw loss plot and accuracy plot. So loss plot and accuracy plot. Next, after that, so okay. Uh, Next, confusion matrix. So confusion matrix. After that, classification report. Okay. So confusion matrix and classification report. Report. So report and analysis, research analysis. So research analysis, analysis on my project based how it is working. Like need to check each and every point. So whether my model is working fine or not, why it is not working, what are the different parameters that I have to change. Next, after that, hyper parameter tuning. Okay. Next, also change the network, change the CNN network and build again. So build again. So build again and try to complete all the steps from step number eight till to the so research analysis on the project till to the approval. So approval like satisfaction level. So approval in the sense means satisfaction level around 95% of my project is working fine. So accuracy. Then we'll stop that. So doing this one. Okay. So this is about something called as how to work on this project. Now I'm going to the code. Here, what is going to happen? So first import. We need to import the standard libraries. Okay. So I'm putting the heading. So import standard libraries. So import. So standard libraries. Okay. So here just it's a subheading import OS. So import. So numpy as np alias name import. So matplotlib. So matplotlib dot pyplot as plt and import cv2 and import pickle. So pickle. So we will learn each and everything in our course. Okay. So import pickle. After that, from TensorFlow dot keras. So TensorFlow dot keras dot layers. So layers, import sequential. So sequential. After that, load model. So load model. Sir, what is sequential? What is matplotlib? All these things we will learn in our course. So from TensorFlow, so TensorFlow dot, so Keras dot, so layers. So TensorFlow dot Keras dot models. Okay. So here, just a second. So TensorFlow dot Keras. So actually layers, these are not layers. Okay. From next TensorFlow. So TensorFlow dot Keras dot layers, import convolution 2D. So convolution 2D, max pooling 2D, and flatten. So flatten, also dense. So dense. So drop out, and after that, so also activation. So after that, batch normalization. So batch normalization. Okay. So these are the layers. Again, after from, so TensorFlow. So TensorFlow dot Keras dot models. Okay. So import, so Keras dot models. So here import sequential load model. Okay. So these are the things. After that, os dot chdr. So here, how to load the data, which is a more important point in the real time. So here, actually, as I said that we are going to collect the data. From where we are going to collect the data? From any database or anything provided from our client side. But here, actually, in real time, we are going to have the three different cases are there. One is GitHub. So code will be available in the, sorry, not code, data. So data set is going to available in the GitHub. Yes, code also available, but we are going to push that code into the GitHub. Okay, this data set. This data set from GitHub we are going to copy. So how to copy means we need to copy the URL. First case. Second case in the S3 or storage. So storage account. So storage account in Azure or otherwise in the AWS S3. So the data will be provided here. We need to collect the data again from copy the URL, or otherwise the next one is in DB database. Again, copy that URL. Okay. So here after that, so if you have this data in your local system, so local system means in our computer, so look for the path. So where exactly it is present. For example, D drive, so Shiva, and inside that deep learning, inside that projects, inside that data set. So if it is available, then collect that path, or otherwise if it is in your Google drive, in your, so Google drive, then how to work it. Okay. So you can collect the URL. So collect URL, or if you want to work in the Google Colab, so Google Colab, just mount the drive. So mount the drive. So that is enough. Sir, any other external sources like Kaggle? So in Kaggle, different persons are providing this data set. For example, so I may have to download that. Don't download. Why? Because the size of the data is very high, around in GBs. So what is the alternate solution means? Copy that URL. So copy that URL and try to work on it. Okay. So this should be the first case that we have to do. Okay. So that is the thing. So these are the different variations that we are going to work. But actually here I am having my data in my local system. Okay. Currently my data is in my local system. But during our course, we are going to explain that all these five variations. So how to all these six variations. So how to collect the data and how to work. Okay. Actually, we'll discuss these things in the machine learning that follows or reflects on the deep learning itself. Okay. So this is the thing. Now I'm looking for the data. So here, how I'm going to looking for the data means this is my E drive and this is my AI material folder. I'm going to the deep learning, under deep learning projects. So this is my project. So here I'm working on the multi-classification. So that this is my project location and I have to provide. See, it is a backslash. Single backslash means it treats it as a escape character. So make it as a backslash. So my system has to understand that this is a path. For that, we are providing two backslashes. Otherwise, only one forward slash or use raw text, forward slash raw text. Okay. So I set the data path. Now, so here, what is my second step means convert that image data. I will show you that image data into the numerical data. So this is traffic data set name. It has a train data, accident images, and also dense traffic images. 900 images are there, and fire accident. So here the count 900, and here also the sparse traffic are there. This is a multi-class classification. So how to set the data for the training, testing, and all these things we will discuss in the regular course. Okay, these are the testing images. Okay, so here inside this, I am having train validation data is there. It is also having the four different subfolders. Okay, now if this is the model, another folder. Here, see that xtrain.npy means this is a numpy created train data, y train.numpy, and x validation.numpy, y validation.numpy. Okay, so because these fundamentals we follow in the machine learning itself, here just I am uh, explaining how we will do the deep learning project. Okay, not like complete things. So I am, and also I am skipping the second case, that is converting the image data into the numerical format. I'm completely skipping because I did it many times, so I'm not showing here. In our regular course we will explain that concept. Now I want to load the data. So here xtrain, so which is equals to, so we need to use the numpy because that is saved in the numpy dot load, and inside that, so go to the folder name model, and what is the data name is xtrain. So xtrain dot npy. So xtrain dot npy. Similarly, so load that y train data also. So x, what is the x and what is the y? So here x is nothing but image information. Y is nothing but class label name, like traffic, dense traffic, fire accident. That name is there, right? So that is nothing but y. So here y val, so x val and then y val. After that, so here, so y val, so which is equals to, so numpy dot, so load, and again type that model, so slash, so y val. So similarly, x val and y val dot npy. So don't forget that format. Just execute this. We got this execution. Okay. Now what I want to do means I want to print that shape of the training image. So training image data. So training image data, comma, x train shape. How to print that means using the command shape. Similarly, so I want to print that class labels. Okay. So I want to print the class labels, and also I want to print the test validation. So training image label. So image label shape, shape. Okay. Training image label shape. Here, just to put that capital Y. So here, Y train dot shape. And here, this is not a test training. So this is a validation. So validation. Image data shape. So image data shape, something meaningful. So here, xval. Similarly here, so yval. So yval. And this is nothing but validation image. So validation. So image label. So label. So data shape. So label data shape. Okay. So this is a thing. And here, if I run this one, see that train image data shape is 3664, 64, 3. Meaning 3600 images are there. Each image size is 64 by 64 by 3. Means 64, 64 are height, width, and 3 is the channel. Okay. But training image label shape is 3604 because we have four folders. So four folders in the, so traffic data inside the train, accident, dense traffic, fire, and sparse traffic. Okay. So this is a classification project. Okay. Classification project. Now I want to display one image. So how to display that image? So plot.imshow. So plot.imshow. And here x train. So x train of 100. Meaning I am selecting the random 100th image from the training data. Okay. So plot.title. So plot.title. Here, so training. So training image. Sir, I am going fast. Why? Because we our students already learned these kind of things. We will learn all these things in simple formats. That's why I am going fast. Okay. So plot dot show. So plot dot show and print. So print here the label. So label. So here white rain. So white rain of whatever the image we have taken, take that same image, like 100th image on. This is my image. Now you can see that module matplotlib has no attribute type title. Okay, typo mistakes. So, okay, now you can see that image. It looks like something like that. It is an accidented image. So forget about that, whatever it may be. So here label is nothing but 1001. This is a one hot encoded of this image. So one hot encoded of this image. What is one hot encoding? Label encoding, dummy variable, all these things we will see. Okay. So after that, so the next duty that I am going to do means, so I'm going to perform the data augmentation. So from so TensorFlow dot keras, so keras dot pre-processing, so pre-processing dot image, so dot image, so import image data generator, so image data generator. So what is the need of doing this image data generation? Okay, so need of doing this because there is some concept behind this. We discussed already about this concept. Okay, so image data generator. So image data generator. And here, so what are the different parameters that I need to change? So here rotation range. So rotation range. So rotation range, which is equals to 15 degrees. Okay, 15. Yes, plus or minus 15 rotation degrees. Okay. Next, after that, zoom range. So next, after that, zoom range, which is equals to 0.15. So zoom in and zoom out. Okay. After that, so width. So width and press the tab after typing that one. So press the tab. So sometimes it will work, sometimes it is not working. Okay. So width shift range. So width shift range that is equals to so 0.10. Okay. After that, so height, so shift range. So height shift range. So height shift range is equals to 0.110. Shear range. So shear range. So what is that shear range? 0.10. And after that, horizontal flip. So horizontal. So horizontal. So flip. So flip, which is equals to so true. So which is nothing but true. So after that, fill mode. So fill mode. So fill mode is equals to nearest. So nearest. So there is a meaning for each and every up parameter. We call them as these are parameters. For each and every parameter, there is a clear explanation will be there. Sir, I don't know about these many parameters, how to remember in the image data generator. Just copy that image data generator and type the two question marks. And here, so just run this. And now we'll ask that. Now you can see that. Meaning, first you have to run this model, imported model. Then only it is going to show you that. So what exactly image data generator means. These parameters are available in this image data generator because I worked on many deep learning projects, so I remembered all these points. But for you, it may be a new, but you will learn once after doing the practice. So width shift range, height shift range, shear range, zoom range, fill mode, horizontal flip, all these things. Okay, we will learn in our course structure. Okay, after that we need to fit this train. So data gen dot fit to the so X train only because we are going to so change this image data augmentation for only train data. Why only for X train? Why not for other? So there is a story behind that one. And the next one is early stopping and then model checkpoint. So from TensorFlow, so from TensorFlow dot so keras dot so here callbacks. These are nothing but callbacks because they are going to work in the backend. So import early stopping. So what is early stopping? Again, there is a story behind it. So early stopping, and after that, so model check point. So model check point, execute this one. So it is also loaded. Now, so create that early stop. So where early stop is equals to, so early stopping. So what is the need of early stopping? There is a clear picture will be there. So story. So after that monitor is equals to, so here we are going to take that monitor is nothing but always validation loss. After that patience. So patience is equals to, we are going to take that file, and after that, so here, so restore, so restore best weights. See, so restore best weights is equals to, so true, and after that verbose. So verbose is equals to 1. Sir, what is verbose is equals to 0, and what is verbose is equals to 1. Okay. After that model, so check point, so which is equals to, again, so we are going to take, so model check point, and inside that we need to save this model, best model. Okay, model slash so best model dot h file. What is meant by h file? Okay, so after that monitor, so monitor is equals to, here validation accuracy. So we are going to save that accuracy of the model in the model checkpoint. Here save best only, the parameter save best only is equals to true. So after that verbose is equals to 1. So verbose is equals to 1. So this is the another concept. Now I got some error. So what is that unexpected keyword argument verbose? Okay. So because here I have taken the capital V, because Python is a case sensitive. So now we applied. Sir, I don't know what exactly the parameters available in the early stopping. Same criteria like two question marks and then ask, it will give the help. Okay. So what are the different parameters are there? What parameters I have to choose? And even for the model checkpoint also take that. So this is the help. Okay. So here after that, so what's the next concepts that we need to do means we need to build the CNN model. This is the so important concept of that entire deep learning project. So I am creating a object reference which is nothing but a classifier, and I'm going to take that sequential here. This is nothing but a class, everything to work in the sequential manner. So that is the thing. Now I am taking the first convolution layer. So classifier, so classy, so classifier, so classifier dot, sorry, so classifier, sorry, classifier dot add. Here I want to add convolution. So convolution, so 2D, okay. So convolution 2D, and inside that convolution 2D, I'm going to first, I'm going to take the filters. I'm going to take that filters. Here I'm taking the 32 filters, and after that filter size. So filter size is nothing but kernel size. So which is nothing but 3 by comma 3 filter size. Why 3 by 3? Why not 2 by 2? So all different things are there. Padding. Next concept is padding. Is nothing but save. And after that, so here input shape. So input shape, we need to provide the input data, right? Where input shape is equals to, so 64 comma 64 comma 3. So that is the thing. Now after that we are going to apply the classifier dot add. So batch normalization again. So what is this batch normalization? Story is there. So once we learn that stories, then it is very simple for to build the deep learning project. Again, classifier dot add. So activation. So activation. So which is nothing but, so which is nothing but relu. So what is this activation means? So again story. So classifier dot add. So add pooling. So not pooling. We are going to take the max pooling 2D. So max pooling 2D. And inside that pool size. So meaning kernel size, pool size is equals to, so 2 cross 2. Why here 2 cross 2? Why not other than that? Okay. So there is a lot of concepts are there. So this is the layer 2 and layer 3. Now I need to change something here, 32 to 64, and here remove this input because we are going to apply input only once. Okay. And the rest of the things are same here. After that 128. Okay, remove this input here, So remove this input here. So okay, okay. So this is called convolution and pooling layer. After convolution and pooling layer, we are going to add the flatten layer. So we are going to add the flatten layer. And after this flatten layer, so what going to come means we are going to get that classifier dot add. So classifier dot add flatten. Okay. So here after that we need to connect the fully connected network. So classifier dot add. How we are going to connect the fully connected network means tens, and this is a hidden layer with 256 neurons. Okay. After that classifier dot add. So batch normalization. So batch normalization. So batch normalization. And after that add classifier dot so activation. So classifier dot add so activation. So activation. So which is nothing but so relu. So which is nothing but so relu. And after that add classifier dot add dropout. So drop out. So why dropout? So what is the duty of dropout? So again story. Okay. And after that add this output layer. So classifier. So classifier dot add. So classifier dot add. So dense. So again dense four neurons in the output layer because of the four classes where activation is equals to here soft max. So what is soft max? What is sigmoid? All these things are there. After that, so classifier. So classifier dot summary. So classifier dot summary. So here it will give this summary. Okay. So how these parameters I got, this how I got, this 896 how I got. We will see that 896 how I got. Okay. So actually we have taken the input image. So input image. So it is having batch size is nothing but none, and 64 cross 64 cross 3. So this is nothing but batch size. So batch size, and this is nothing but height. This is nothing but width. This is nothing but channel or filter. This is nothing but channel or filter. And after convolution one, this is my output. So for the image. So what is that output means? None. Again, so I didn't remember that. So now you can see that convolution 2D, none 64, 64, 32, 64, 64, 32, 64, 64, 32. Okay. So this is the thing. And here there is a mathematical formula is there. Current filter. Okay. And previous filter, sorry. So previous filter, this previous filter multiplied by kernel size, kernel size um, plus 1. How I got this formula? So there is a history behind that. But for the sake of now, we are just seeing that what is the first, how I got 896 parameters. Okay. We will study that one. This is the current filter size. That is 32 multiplied by what is the previous filter. So previous filter size is this one. So this is channel or filter. 3 multiplied by what is the kernel size we have taken? 3 by 3 kernel. Okay. So 3 multiplied by 3. And why we are adding 1 means this 1 is nothing but bias. Every neuron, 1 bias per 1 neuron. 1 bias per 1 neuron. Okay. So 32 channels, 32 neurons, 32 bias. Okay. So 27 plus 1, 28. 28 multiplied by 32. So 16, 4, 5, 24, and 8. So 896. This is how I got this 896. Now how I got 128 batch normalization. So batch normalization. So batch normalization. So actually batch normalization follows two concepts. So one is trainable parameters. So trainable parameters. And the next one is non-trainable. So non-trainable statistics. Non-trainable statistics. Trainable parameters are two types. One is nothing but gamma and beta. So beta. So beta for the shift of that image, gamma for the scale of that image, and What are the two non-trainable statistics are running mean. So running mean and running statistics, running variance, running mean and running variance. So each one will take the number of current filter size, that is 32, and beta will take 32, running mean take 32, variance take 32. 32 multiplied by 4 is nothing but 128. Okay. And that is the formula for batch normalization is 4n. Okay. 4n. Okay. Now, so next, what are the parameters? How I got to 18,496. Okay. So see that one. What is the input here now? So what is the input now? Previous layer, that is none, 64, 64, 32. This is previous layer. Convolution, this one is there, right? So convolution one output is input to the convolution two. Okay. Input to the convolution two. And what is the convolution two output? So let's collect that one also. Okay. So it is reverse. So it is reverse. Like output none, 32, 32, 64. So we'll see that yes, 32, 32, 64. Because of the after convolution operations, it will reduce. Now, what is the formula? So current filters multiplied by previous filter multiplied by kernel size plus 1. Here, what is the previous filters? Previous filters are 32, this one. And multiplied by kernel size is 3, comma 3. And after that plus 1 multiplied by 64. Definitely it is going to give 18,000 496. 18,496. You can calculate it. Definitely 100%. So correct result. Okay. Like that, we are going to follow this classifier parameters. Okay. So this is about something called classification summary. So total trainable parameters, non-trainable parameters 960. Total trainable parameters are so these many members. So non-trainable parameters are nothing but so batch normalization. In that batch normalization, half of them are non-trainable. Okay. So that is the thing. And pooling and max flatten has no trainable parameters. Okay. After that, compile. So compile. So compile classifier dot compile. Sorry. So classifier dot compile. So we need to compile. So here back propagation we are adding. So optimizer. So optimizer. So where optimizer is equals to Adam. And after that, so loss, where loss is equals to, there are different loss are there. So categorical cross, so entropy. So categorical cross entropy. After that, so entropy, comma, metrics. So where metrics is equals to accuracy. So we are interested in the accuracy of the model. This may change sometimes, depends upon the, so how it is going to get. Okay. So after that, sequential object has no attribute. So complete. Okay. Spelling mistake. Compile. It is compile. Now we added the compile. Okay. So after this, our duty is to train the model. So how to train the model? Where history is equals to so classifier dot add. Okay, not add, classifier dot fit. We need to fit the train data, right? So here train data gen. Inside that we are going to provide the x train. So x train comma so y train comma batch size, where batch size is equals to 16. Okay, batch size is equals to 16. After that, validation. So validation data which is equals to, so here, so validation data is equals to x train data gen dot flow. So train data gen dot flow. Otherwise, it will give an error for us. Okay. So here validation data is equals to so y val. So sorry, yval comma xval. Sorry, second one is validation yval. First we need to give that xval, yval. Okay. Now after that, so epochs. So epochs means training, which is nothing but 50. And so here callbacks. So callbacks is equals to, so here early stop. So early stop. So what we have taken previously early stop, and also we are going to take the model. So model checkpoint. So what are the names we have taken? That is more important. Otherwise, we'll face some error. We will face that error. This is the help code. So here, this is the model checkpoint, that is early underscore stop. Okay, model checkpoint. Okay, now close this one and then run. So it will start running the project. So epoch one. So here, what is 225? What is batch size is equals to 16? Meaning here, batch size is equals to 16, meaning 16 images per batch, 16 images per batch. So per batch, total images is 3600. We have already taken the shape. 3600 by 3600 by 16 will give 225. So 225 batches are there. Each batch has 16 images. What is meant by iteration? So iteration means one forward propagation plus one backward propagation. Okay, one forward propagation, one backward propagation. So actually, during this, what is going to happen means one batch for one batch, 16 images are trained during this one iteration. Okay. So one epoch. So epoch is equals to one means 225 iterations, 225 iterations. Okay. So why? Because 225 batches, each batch, one iteration. What will happen in the epoch? Okay. One forward propagation and one backward propagation and loss calculation. And then during this backward propagation, weight updates. So weight updates is going to happen. So weight updates is going to happen. That is the thing. Okay. Now you can see that second above because of this model, this is the GPU. That's why it is running fast. Otherwise, it take around 1 hour, 2 hours, one full day or 1 week. Also, it may take depends upon the so the size of the data and then project. Okay. Next, we need to save the history. How to save that history? So with open, so open here. So I want to save inside the folder model slash history. So history dot pkl. So pickle. So pickle is a library. So there is a cinema behind that also as a right binary as f. So after that, so pickle. So yes, pickle dot dump. So pickle dot dump. And inside that, we are going to save that history dot. So history. Okay. Then we are going to pass that f value. So after this saving the model, I want to predict. So I want to predict on the image, right? How to predict on the image? Take that image, any one image. So use CV2, open CV. CV2 dot im read means image read. So where it is present. So one test image, go to the folder here. So here, back testing images in that, collect any one image like images.jpg. Here, look at this folder name, testing images. Okay, I'm copied that one. So here I'm pasting that and then images.jpg. The name of the image is images.jpg. After that, so where image is equals to cv2 dot resize that image. So how I am going to resize that? Which image? That same image I want to resize as 64 comma 64. So spatial dimension I added where text is equals to so image dot as type. So as type we need to convert that image into numerical format. So for that I am using as type floating point 32. Okay, 32 bit. So divided by 255.0, which is nothing but normalization. After that text is equals to numpy dot expand. So expand dims means a dimension of what? Test image, comma, axis is equals to 0. So what is the meaning of this axis is equals to 0? Previously, we have taken the image size, which is nothing but none, 64, 64, and then 3. This none is nothing but batch size. But for this test image, we have only 64, comma 64, comma 3. But there is no batch size. We need to add that batch size 1. Okay. So batch size as a 1. So why we need to add 1 or none, whatever it may be here, it reflects here. This is nothing but 0. This is 1. This is nothing but 2. And this is nothing but 3 index values. Okay. So we need to add that one. So batch size for the test image. After that, so prediction. So prediction is equals to classifier. So classifier dot so predict. So classifier dot predict on the test image. Okay. After that, predicted class. So predicted class. So I want to know that what is the class name. So whether it is fire accident or whatever it may be, I want to know. NumPy dot argmax, NumPy dot argmax. There is a story behind that. So what is meant by argmax also? Okay. After that, confidence. So confidence. So which is nothing but so NumPy dot so max NumPy dot max of so prediction. So NumPy dot max of prediction. So after this, okay, so print. So print. So class predicted class. So predicted class. So predicted class. Okay, comma uh, predicted underscore class. So whatever the name we have given. After that, print that confidence also. So confidence. So prints confidence. Okay. So confidence. So confidence. Okay. So confidence. Now after that, I have to add one more concept here. So after this, what I have to do is I would like to take the class names. So where class names is equals to so in the dictionary format. So zero belongs to 1 and 1 belongs to so sorry 1 belongs to other class and 2 so belongs to other class and 3 so belongs to other class. Okay, then close it. Here what is this? So one, so how to add these names? So usually how we have taken inside the data, this order is going to follow accident to dense to fire sparse. Okay, so accident so dense traffic, dense traffic. Here, fire accident, so fire accident, and here sparse, sparse traffic means low traffic. So sparse traffic. Okay. So these are the class names that I have added. And after that, I want to know the label, which is equals to so class names of predicted class. So class names of that predicted class. So predicted class, it will give that one. So print label here. So print label. So, okay. So print label. After that, so what we have to do? So here, so show the output, display that output. How to display that one? Where display. So which is equals to so CV2 dot resize CV2 dot resize image comma size of that image is 500 comma 500 I have taken. After that CV2 dot so put text. This is a command in OpenCV. Okay. So on which image you have to write means that is the name of that. And after that what you have to write label means what is the predicted one label and which location. So in the X and Y location 20 comma 40. After that so CV2 dot font. So that text font. So font. So uh, sorry, font RC simplex. So this is one of the standard font. Okay. After that, so one that size of that text. After that, color. Which color I want to represent that text. After that, thickness of that each character. Okay. Now CV2 dot IM show. So CV2 dot IM show here. What I are going to show means prediction. So we are going to show the prediction and we have to window name. So this is the name of the image and this is which image. Okay. After that CV2 dot so wait key. So we need to add the wait key. So otherwise, so it will give it won't close that. Okay. So it will give some error. CV2 dot so destroy all windows. So destroy all so windows. Okay, destroy all windows. So here now you can see that early epoch 10 early stop loss is 0.5, accuracy 8, 0.8, validation loss 1.7, val accuracy is equal to 0.3. Okay, so for the sake of that, now we are going to run this image. Now you can see that it is predicted as a class 2 with the confidence as 0.9955. We don't know that what exactly. Fire accident, whether that image is a fire accident or not. Now you can see that this is a fire accident. Okay. Now, so we have predicted that image 100% successfully. Now plot the accuracy plot. So how to plot that one? Plot that figure and inside that fixed size. So where fixed size is equals to So here 8 comma 6, you can set 8 comma 6. After that, plot dot title. So for this, so before that title, so we need to take that history. So plot dot plot. So history, and inside that, so we are going to take the accuracy of that model. So after that, so we need to take the label. So label name is equals to here. So what is this? So training accuracy. So training accuracy, we need to compare the accuracy of the train and accuracy of the validation also. So here, so plot dot plot history here. So instead of that accuracy, add a val in front of it, val accuracy, and this is validation accuracy. So this is validation accuracy. After that, now plot dot title. So what is the name of the title? So actually title is not required. Before that, we need to take that label. X label is nothing but so epoch, and after that plot dot y label. So y label. So here is nothing but accuracy. So y label is not accuracy, and plot dot title. So plot dot title. Now, so training versus validation. So validation accuracy. So training versus validation accuracy, and plot dot legend. So plot dot legend, and then so plt dot show. So plot dot show. So these are the training and validation accuracies. How we got. Okay, we also have to plot the loss curve history dot history. Here we need to take that loss. So training is represented with loss. Sir, how would I know all these things? Because of here you can see that clearly mentioned. Here clearly mentioned. Loss, these names we have to collect. Loss, loss accuracy, validation loss, validation accuracy. That is more important. Okay, now here this is nothing but validation loss. This is nothing but training loss. So training loss, this is nothing but so validation loss here, epoch versus so loss, so loss. So here training versus validation loss. So plot dot legend, plot dot show. So this is the loss curve. We need to analyze this loss curves, but I am not analyzing here. So we will analyze that in the real time. Okay. Now after this, now I have to print the confusion matrix. So from sklearn dot metrics, because calculations metrics. So import, so confusion matrix. There is a story behind this confusion matrix. Also classification report. So classification report. So classification, so report. So execute this invalid metrics. Okay, from space. So sklearn dot metrics, import classification matrix, and all these things. Also, we need to load the classifier first of all. So classifier. So first load that classifier. Classifier is equals to so load underscore model. Okay. Now after that, where exactly that model is. So we have given the name as best model dot h5. So h5. Okay. So after this loading, now predict on the so y predict is equals to so y predict is equals to here classifier. So classifier dot so predict on the X validation. So on the X validation, why only on the X validation, why not on the other? And also after this, so Y true. So Y true is equals to numpy dot argmax of Y val. So because we have these are one hat encoded, we need to convert this into the so class indices where axis is equals to one. So similarly, y predict. So y predict is equals to numpy dot argmax of so y predict numpy dot argmax of y predict where axis is equals to one. Okay, so we need to convert back to the class indices. After that, CF confusion matrix, which is equals to so confusion matrix of okay. So y true. So y true comma y predict. So y true comma y predict, and after that print this CM. So it will give the confusion matrix CM. So it will give the confusion matrix. We have to study this confusion matrix also. And after that here, so classification report. So classification report. So how to work on the classification report means first we need to take the class names. So class names is equals to so list of the names. Okay. So comma and four. So what are those? First one is accident. Second one is dense traffic. So dense traffic. Third one is fire accident. So uh, fire accident. Okay. So last one is sparse traffic. So sparse traffic. Okay. So this is the class names. Now classification report. So we have to take the classification report. So how to take that classification report means print. So classification report, and inside that, so again y true. So what is meant by y true? What is meant by y predict? All these things has some history. Next, target names. Target names is equals to so class names. Target names is nothing but so class names. Now, if you take this one, so int object has no attribute length. Okay. Was not names, named. Now this is the classification report. We need to analyze precision, recall, F1 score support. Also, we need to analyze about the accuracy, macro average, and weighted average. And this is just one simple project, but still lot of concepts are there, and we need to perform some research on this. Then we finally decide this project whether it is okay or not. If it is okay, then what is the duty of the next means we need to push this one into the Git GitHub, and then we need to perform the ML ops or so AI ops operations into the production level. So here, up to now, that is the duty of AI engineer or ML engineer. This is the duty of AI engineer or ML engineer, whoever may be. So it is going to work this kind of stuff. Okay. So that's it. This is the just one project. Just I have to discuss it for the sake of that people may know that, because most of them are asking like students in the introduction session only itself, they are asking me, sir, can you, why don't you explain at least one project for us? We would like to know that whether can you explain a project properly or not. So everyone is having some kind of trust issues. Why? Because most of them don't know that whether we complete it or not, because most of the organizations in the outside, what they are doing means when we are going to come to the ML, they are stopping the teaching after ML. They are stopping the deep learning, NLP, all these concepts because of the issues. Some issues, maybe trainers are not properly trained well, like maybe number of days, all these things issues. So some of them asked me, can you please teach me the deep learning project so that we will have some trust on you, so that we will join the course and all these things. That's why I have created this project. So you can go through it, and you can try to work on the different deep learning projects. I have multiple projects are there. Also in future, we are going to create our own agents. And if anybody interested to connect to me, then you can connect to me so that we will work in parallel also. So that's it for the today. Thank you.